All right, so now we're going to do angle, side angle, and angle, angle, side. So we're on page 273. Two learning targets. Use the angle, side angle congruence postulate to prove two triangles are congruent. Use the angle, angle, side congruence postulate to prove two triangles are congruent. Our book calls these postulates. They're actually theorems. These can be proven to work. All right, we'll stick with postulate though if that's what they want us to call them. All right, now kind of like the side angle side, you could use your eyes to trace out the different parts. That's what's going on here with angle, side angle. Now, we had an included angle with side angle side. It was the angle formed by the two sides we were talking about. Well, with angle, side angle, now we have to have an included side. The included side is the side between the two angles we're talking about. Okay? So the book says it this way. An included side is the side located between two consecutive angles of a polygon. So for instance, segment AC is included between angle A and angle C. Okay? Now the way angle, side angle works out, it says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. And we can do this again. We've got two angles. Notice that segment AB would be the included side between angle A and angle B. And then we move it over here. Maybe we'll move it over here. Wow, that's frustrating. There we go. There we go. And we have the two angles and the included side. This time it's segment DE that's included. All right? So we do get congruent triangles out of that. Everybody with me? So instead of calling it the two angles and the included side theorem, they call it angle, side angle, so that when you're looking at it, you know, you'll see an angle, then an included side, then an angle that are congruent to an angle, an included side, and then the other angle. See how it works? Let's try it. Oh, we know our reasons. Let's try one. So number one, over on page 276. Now, we'll try to follow the directions as to what kind or what type of proof to do, but I'll tell you this too, though. The most important type for us to be able to do is a two-column proof. So if it confuses you to do a paragraph or a flow proof, I'm okay if you back up to a two-column proof. I want you to try the others. I want you to do those, especially the paragraph. I want you to do the others. But you may find it easier to do a two-column proof and then convert it to the other type. And you may not. You may like the other types better. But two-column is going to be the kind you run into on the ACT, you know, where they'll ask you what's the correct next step kind of thing and all that. So that's the most common type for high school students to be able to do is the two-column proof. You know what you got to do. Take some writing. You write down your given. Segment CB bisects angle ABD and angle ACD. And we have to prove that triangle ABC, that's the triangle in the upper left, is congruent to triangle DBC. That's the triangle in the lower right. So write what you're given, write what you have to prove, and draw your figure. And I'll give you a second to do that. We need a column for statements. We need a column for reasons. And what's our first statement going to be? Segment CB bisects angle ABD and angle ACD. And what's our reason? Given. So look, we can get all this done, and that's, I mean, let's, you know, I guess we haven't done a whole lot, but it looks like it on your paper. So we can get all this done, period, right? We can. Now, let's look at our figure. Let's do some thinking. Let's make a plan. We're using angle side angle this time, all right? So that makes it a little easier to know what you're aiming for, all right? They get a little tougher when all of a sudden we know 4 different methods and you don't know which of the 4 is going to be the one that works. Okay, so what does it mean for an angle to get bisected? It's divided into 2 equal halves. All right, so in other words, it gets divided into 2 congruent angles, doesn't it? So if angle ABD, this one, gets divided into 2 congruent angles, aren't the 2 congruent angles that one and that one? And then the same thing happens to angle ACD. It gets divided into 2 congruent angles. So that angle is congruent to that one. We know it for a fact, don't we? Let's put it in our proof. Oh, by the way, do you see where we're going with this now? Because segment BC is included between those angles in each of those 2 triangles, isn't it? So that's how we're going to get the angle side angle. So we figured it out. Now we got to write it. So angle ABC is congruent to angle DBC. Angle ACB is congruent to angle DCB. And what's our reason? How do we know those angles are congruent? Yeah, because that's what an angle bisector does. Whenever the reason is because that's why, because that's what it does, what you're really trying to say is that's the definition. Okay? So that's the definition of angle bisector. Now, we said that we knew that segment BC, we know 2 things about segment BC. We know that it's congruent to itself because of the reflexive property, and we know that's useful because that sets up our angle side angle. So, we know it's congruent to itself because of the reflexive property. Put it in your proof. Segment BC is congruent to segment BC. Reflexive. And what's step 4? What's statement 4 need to say? Yeah, we're ready. Triangle ABC is congruent to triangle DBC, and the reason is angle side angle. Any questions? All right. What do you mean, which one you use? You mean like side, 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 that kind of thing? Whatever works. Okay? And like I said, that's what makes these a little more difficult as we learn more methods, because then you have more choices. So it's one of those double-edged things. More choices means you're more likely to be able to prove it, but more choices also means now you got to try to figure out which method's going to work. And depending upon what information they give us, there may be more than one method that will work. Okay? All right, let's do number 2. This time they want us to do a flow proof. Let's try to do a flow proof together. Okay? So go ahead for number 2 and write down your given, what you have to prove, and draw your figure. No, we're not doing 2-column, are we? Now, when I see parallel lines, I know what I think of. When you see parallel lines, do you think of transversals and a bunch of different angle pairs that might be congruent? Yeah, that's what I think of too. That's what you need to think of. All right, so, and they've already got it marked on the drawing here for us. Segment JK is parallel to segment LM. Segment JL is parallel to segment KM. And then we're having to prove that triangle JML, that's the one on the bottom left, is congruent to triangle MJK, upper right. Well, I see that those two triangles share a side. I love it when that happens because I can always use the reflexive property and get one pair of congruent sides that way. I don't guess I always will use it. Maybe I won't always use it, but at least I know it, right? So I know that segment JM is congruent to segment JM, and I know that JM is in both triangles. Now, what else do I know? Well, if these two lines are parallel, and that's a transversal, here and here we have a pair of alternate interior angles. So that's one pair of congruent angles. And then here and here we have parallel lines. Use this as your transversal. And now that angle and that angle are a pair of alternate interior angles. They're congruent. Oh, I'm in really good shape, aren't I? Because I've got two pairs of congruent angles, and then the side that's included between those congruent angles is this side right here, which we already said is congruent to itself. So I've got it planned out. I can make it work with angle side angle. Now I just got to write it down and make it work with angle side angle. All right, so flow proof. In a flow proof, we tend to put things in separate little boxes. So we'll do this. We'll put segment JK is parallel to segment LM, and then we'll put a little box around it. Then underneath, we write the reason given. Segment JL is parallel to segment KM. We'll put a little box around it. In a flow proof, they like them in separate boxes. One of the things I don't like about a flow proof. Would I count it wrong if you put them in the same box? No. All right. Now, since JK is parallel to LM, let's see where that leads us. So I'm going to go ahead and even do that. That's going to lead us to know a pair of congruent angles, isn't it? We'd already planned that out. So which pair was it? It was that side, that transversal. So it was this angle, oops, this angle, and this angle. So what do you want to call one of them? Angle KJM is congruent to angle LMJ. So let's put that in a box. Why is that true? Alternate interior angles theorem. All right, because of our other pair of parallel lines. It was segment JL and segment KM. That's the transversal, so it's this angle and this angle that we're talking about. So what do you want to call one of those angles? Angle LJM would be congruent to angle KMJ. And what's our reason? Alternate interior angles theorem. So that gives us our two pairs of congruent angles. I haven't stated that side yet, have I? Okay. Our pair of congruent sides are the same segment. It's segment JM congruent to segment JM. And how do I know that's true? Reflexive. Yeah, our book tends to, our book would have written that box up here just because they like to, and I don't know why they do, they like to fill in that. And look, well, I bet you can tell me, why do you think I put it on the same line as those other two things? Because when I put those three together, that gives me the angle side angle. So to me, it seems logical to put them all on the same line. Is it required? No. Okay, as long as it's in there somewhere and you can draw arrows from it leading to our conclusion. Because now that we've got our two pairs of congruent angles and that one pair of congruent included sides, we can state that the triangles are congruent. So our final statement is triangle JML is congruent to triangle MJK. And what's our reason? Angle side angle. And I need to draw arrows from those three pairs of congruent corresponding parts. So I draw an arrow from that one, and from that one, and from that one. You like flow proofs? Yeah, I'm afraid I prejudiced you against them. I don't mean to, because I'm not a big fan. But some students like them a lot. And so if you do, you do. If you don't, you don't. We're going to do some. Okay? Questions? Okay. Well, let's see. We had another method we're going to learn in this section. Angle, angle, side. Now, this is actually the most difficult one to apply that we're going to have because of that side is not included between the two angles. So it says, if two angles in the non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. You're thinking, well, how's that any harder? Well, it's not on the surface. Look what we've got here in triangle ABC. I've got an angle. Segment BC is a non-included side, correct? Then look at the other triangle. Angle D, congruent to angle A, angle E, congruent to angle B, and then segment EF is also a non-included side, and it does correspond to segment BC, doesn't it? So on the surface, hey, it's just like the other ones. You need 3 pairs of parts. As long as you can find the angle, then the non-included side, you're good. Let me show you where it gets tough. People confuse it this way. Pretend that that little thing's not there. Segment BC and segment DF are not corresponding sides, are they? So it's angle, angle, non-included side for this triangle. It's angle, angle, but the wrong non-included side for this triangle. See what I'm talking about? So that's why the theorem bothers to say corresponding. They didn't say that in the others because it worked, okay? But it's got to be that the 2 angles aren't the problem. The thing you've got to make sure of is that your non-included sides are actually corresponding to each other. That's what you got to make sure of, okay? And here's one way to make sure of it. In triangle ABC, I went 2 arcs, 1 arc, side. In triangle DEF, I can't go 1 arc, 2 arcs, non-included side. That's backwards, isn't it? So you've got to be able to go in the same pattern in both triangles. As long as you can, everything's good. So angle, angle, and then corresponding non-included sides. Questions? Let's use it. And there's the proof, and I've decided we'll just go right to number 3. Page 276 again. This time they want a paragraph proof. Write down what's given. Angle K is congruent to angle M. Segment JK is congruent to segment JM. And segment JL bisects angle KLM. Write down what you have to prove. Triangle JKL is congruent to triangle JML. And draw your figure. All right, so let's plan it out like we always do. I see 1 pair of congruent angles, and we need to make sure then if we're going to use, and we know because I'm telling you, we're going to use angle, angle, side. Okay? So it's an advantage to know that. If that's what we're going to use, then segment JK and segment JM need to be the non-included sides, don't they? Which means it'd be sure be nice to know those 2 angles are congruent, wouldn't it? Are they? Yes, because angle KLM gets bisected. So once we put that in our proof, then we do have angle, angle, side all set up, don't we? There's your first angle, there's your second angle, there's your side, there's your first angle, there's your second angle, there's your side. So angle, angle, side. Does the plan make sense to you? Let's see if we can write it in then. So let's put all the given in there. So let's say that angle K is congruent to angle M. Segment JK is congruent to segment JM. And segment JL bisects angle KLM because it is given. Isn't that almost exactly what we would have said in a two-column proof? Okay. All right, then let's follow our plan. We want to say those two angles are congruent. So angle KLJ is congruent to angle MLJ because why? Because of the definition of angle bisector. All right. Now what do we say? Triangle JKL is congruent to triangle JML because of angle, angle, side. And you never have to write out angle, angle, side. You can always put AAS. All right. Now, I wrote this proof, I wrote those sentences like this on purpose so that you'd see it's just like doing a two-column proof. Are those kind of boring sentences? Yeah. Is that okay? Yeah. All right, just make your statement, say because of, put your reason, and you've turned it into a paragraph proof. You don't have to do it that way. You can change your sentences up, but you can do it that way, and that's no more difficult than a two-column proof. We good with number 3? Number 4, do it. You can use angle, angle, side. That's your hint. All right, now, I kind of expected you might leave out step 2. Did y'all think to put in step 2? Yeah, it's really hard to think to put in step 2 because did you do the rest of it the same way I did except for step 2?
I did them in a different order.
Different order's fine. Sometimes the order matters, you know, like with the flow proof, one arrow leads to something else. But then sometimes it doesn't. It's just a matter of would I rather say this first or this first. So don't worry about that. All right, now here's what, do you see why you got to put in step 2 now that you see it? It's one of those details that we talked about. Because what they told us was that the measure of angle G and the measure of angle J are both 90. They didn't tell us they were congruent. Our theorem, or our book calls it our postulate, angle, angle, side, requires the angles to be congruent. So when we see that their measures are equal, we all think to ourselves, good, there's a pair of congruent angles. But you got to write it that way. Okay? So it's a detail that it's easy to overlook, but it's a detail that is necessary. All right, so here's what I did. Since those two angles are 90, they're congruent to each other. So step 2, saying that angle G is congruent to angle J. Reason, definition of congruent angles. They have equal measures. We were told that in step 1, that's given. They have equal measures, they're congruent, because that's what congruent means. So definition of congruent angles. Then angle GHF is congruent to angle JFH because of the alternate interior angles theorem. All right, that's parallel to that. There's your transversal, so there's your pair of alternate interior angles that are congruent. And then segment FH is congruent to segment FH because of the reflexive property. And then that's enough. We've got a right angle in that angle, then a non-included side, right angle, that second angle, non-included side. So the two triangles are congruent by angle, angle, side. Questions? There's not another pair because that would require knowing that these are parallel. And we can actually figure that out, but you'd have to figure that out in your proof. Okay? Any other questions? I'd take that, yeah. Yep, I sure would. Any other questions? Okay. So look, we've got 4 methods now. We've actually got 5. You can always use the definition of congruent triangles, but will you ever use the definition of congruent triangles? No, because before you get to all 6 pairs, you're going to hit one of these 4 methods. Okay? So side, 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 angle, 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 side. Now, since in this section we just learned angle, angle, and angle, angle, side, they can all be done using one of those methods. One of the other methods might work too. I don't know. I mean, like I've been telling you throughout the lesson, once we're done with this section, and I'm just giving you proofs to do, it does get a little harder because which one's more likely to happen? I don't know. Because it does help a little bit to know which one's more likely. Okay? So those are your 4 methods. You're going to need to know them. You're going to need to know them well. There's another method that has kind of fallen out of favor, and I don't really know why. For a right triangle, and I guess it's because it only works for a right triangle. Okay? For a right triangle, it's called the hypotenuse leg theorem. For a right triangle, if you have the hypotenuse and the leg of one right triangle congruent to the hypotenuse and the corresponding leg of another, then the triangles are congruent. Right, which we don't want to get into. Because, and I'm probably right, but anyway, we might run into this. All right? It's not in our standards. It won't be on a Kentucky test. You might see it on the ACT. I'll try to find a problem here in the next couple days if this is the method you have to use. But it's the hypotenuse leg theory. So if you have two, and what's the only kind of a triangle that has a hypotenuse? A right triangle. Okay? So if the hypotenuses are congruent, and a pair of corresponding legs are congruent, then the two right triangles are congruent. Hypotenuse. I think it's hypotenuse. We're going to call it hypotenuse. Okay? Now, here's your assignment.